You watched the first video, you saw where the properties of logs come from, and now I'm just showing you, here's what we came up with. This one, the power one, is slightly different because I'm just using different letters to keep it x and y. But I'm showing you here how similar it is to the exponent version. When you multiply with the same base, you add the exponents. So when you add two logs, you multiply the inputs, the x and the y. When you divide with the same base, then you subtract the exponents. So when you subtract two logs, you divide the inputs. And then this one's a little bit different. When you raise a power to a power, you multiply the exponents. But here, if we've got an expression with an exponential part inside, we can move that y, that power, out into the front. So let's see how to use this. We've got this expression here. We want to try to rewrite it as one of these versions. And so just kind of ignore the options right now and focus on this. How could we write this as 2 logs? Log base 3 of something plus log base 3 of something. And so we break up this 9 and the x. The 9 is the first input, and the x is the second input. It doesn't matter what it is. We break it up. So there's 9 and there's x. And I can rewrite this like this. Just another kind of quick example without a variable. If we had something like this, log base 3 of 9, log base 3 of 27, I think I did this before, we can rewrite this as log base 3 of 9 times 27. That's kind of how it works, how it would work out. And 3 to the second power is 9, 3 to the third power is 27, 2 plus 3 is 5. And so this, if we got out our calculator, 9 times 27 is 243. So log base 3 of 243 must be equal to 5. And that's true because 3 to the fifth power is 243. Okay, so now that we have this, log base 3 of 3, or log base 3 of 9, we just did it up here. It's equal to 2. So we can simplify this down to 2 plus log base 3 of x, which is that one. Okay, another example. This time we're going to use the quotient property because I see a quotient right here. So break this, write this as 2 different logs. Log of what minus log of what. And notice it just says log. That means log, common log, which is log base 10. So we don't even need the 10. Just have to remember it. So now the top number goes first. The denominator, the bottom number, goes second. We can't simplify this part, but this is equal to 10 to the what power 3. So this would be log of x squared minus 3. Let's see. I don't see that anywhere, but I see this right here. So for some reason we just didn't simplify it. Log of 1,000 is actually equal to 3. So next one. Which of the following is equivalent to log base 2 of square root of x over y to the fifth? This time we're going to have to use 2 properties in one. First, rewrite it as log base 2 of something minus log base 2 of something else, because quotient means subtraction. Put the top number, numerator, and then the bottom number. And now, this power can move in the front, like I said before, because of this property right here. So that becomes 5 log base 2 of y. And this has a power of 1/2. So we can move that power of 1/2 in the front here. And now it's just x. Remember, square root of x equals x to the 1/2. It's going to come up over and over and over. So now this expression is equal to this, 1/2 log base 2 of x minus 5 log base 2 of y. Okay, another one. See a minus, and I see 2 logs. So now we're going to combine and condense into 1. So when you do that, we want to make a big parentheses. Now we take this expression on top and this on bottom using the quotient property, this one right here. So x squared minus 16 goes on top of x plus 4. I don't see that anywhere because we've got some factoring to do. X squared minus 16 equals x plus 4 times x minus 4. Remember, that is a difference of two squares. I could take the square root of both of these. The square root of 16 is plus or minus 4. So then really what we have is x plus 4 times x minus 4 divided by x plus 4. And we'll do a lot of these much later, but this cancels out. So we just got log base 4 of x minus 4. So that would be this one. Okay, one more. The expression log base 3 of 7 plus log base 3 of x can be simplified. So we see a plus here, so it's got to be the product law. So condense it, and that means we have to multiply these two numbers together. So it's just log base 3 of 7x. Okay, this one doesn't have variables anymore, so we've just got some number choices. And so now we don't really need these laws for this problem. We can just take this first, 2 to the second power is 4 times 1/2. So I can rewrite this over here. I'd like to use the parentheses. So that's 1/2 times 2, because 2 to the second power is 4, plus 2/3 log base 2 of 8. So 2/3, what's log base 2 of 8? 3, because 2 cubed is 8. So then we cancel this out. 2 cancels out. This is like 1/2 times 2 over 1. That's just 1, plus 2/3 times 3 over 1. These cancel out. So this is just equal to 3. Okay, maybe you're wondering, can my calculator do this? Let's get out the beast mode. Beast mode, here we are. Can I type in, let's see, 1/2 and then times log base 2 of 4. So I see a log button, but now that's log base 10. How do I change it to log base 2? Oh, we don't have another button for that unless you have a different calculator. So sorry, folks. Beast mode can't do this one as is. We'll learn a different way to do this on the calculator, but for now, we got to do this by hand.